Hello everyone, welcome back to another geography class. Today we will be talking about wind direction and strength, okay? So you guys are now familiar with what wind is and how it is formed from last week's class. This week we are going to talk about the direction wind goes in and its strength. So I'm going to need you to open up to pages 54 and 55 and get your notebooks out so we can get started. Okay, so like usual, I'm going to start off the video with another video to kind of give you guys a good idea of what's going on and recap things. Okay, so just pay attention to this and then we'll get started.
It's what we call wind. When air moves, it's what we call wind. Although we cannot see wind, we can feel it and see it blow leaves, flags, and washing that has been hung out to dry. Winds are changeable, but some are more predictable than others. Weather forecasters try to work out where wind will blow and what weather the wind will bring. They are most interested in wind direction and wind speed. A wind vane is used to show wind direction. It is placed on top of a building or a large pole called a mast, and the wind causes it to move and point in the direction that the wind is coming from. For describing wind direction, we use compass points: north, east, south, and west. Wind direction is the direction wind is blowing from, not where it is blowing to. Therefore, if wind comes from the east, we call it an easterly wind. At an airport, you may see wind socks. They are also used to show wind direction, but they show where the wind is moving to. It is also useful to know wind speed. To measure this, we use an instrument called an anemometer, which looks like this. The faster the wind, the more quickly the cups on the anemometer spin around. It is important to know the speed of a wind. The faster it is, the more damage it can do. We have different words to describe how fast a wind is blowing. A gust is a sudden rush of wind which can catch you by surprise. A gale is a very powerful wind. It can be hard to stand up in a gale, and it's best to stay indoors.
Okay guys, so that was the end of the video. Now, everybody should have their books open to pages 54 and 55 right now. And we are going to go through the book and answer some questions. Okay, so everybody should be on page 54. So, we describe the wind by talking about its strength or speed and the direction in which it is blowing. Okay, so how can we see the direction the wind is blowing in? Wind direction. We can see the direction the wind is blowing by looking at a weather vane on a tall building or a flag on a flagpole. We name a wind by the compass direction from which it blows. So a north wind is one that blows from the north towards the south. Where does the south wind blow? Okay, so clearly if the south wind blows, then it's going to blow from, so we said that the north wind blows from the north to the south. So that means the south wind would blow from the south to the north, okay? So usually we can see the direction the wind is blowing in by looking at a weather vane on the top of a building. And if you guys don't know what a weather vane is, like in the video it showed you, it's kind of like this one thing on top of a building that spins around, and it has a compass around it, so north, west, east, and south. And depending on the direction the wind is blowing in, that's where, usually it's a chicken as well. The vane is shaped like a chicken. The chicken will go towards that direction the wind is blowing in. Or a flagpole. So the flag on a flagpole, if you go out, like, there are flags pretty much everywhere, all right? And if you just look at a flag on a normal day, you will be able to tell by the way the flag is, blowing, what direction it's going in, and if it's really windy or how heavy the wind is, okay? So yeah, we can see the direction the wind is blowing in by looking at a weather vane on a tall building, or a flag on a flagpole. How do we name wind? Oh, and guys, by the way, this is a vane. This is what I was just talking about, okay? So how do we name wind? We name wind by the compass direction from which it blows. So do you see this vane right here? So depending on what direction, this little arrow will point towards the direction the wind is blowing in on a windy day, okay? So if it is blowing towards the south, then this chicken will be moving towards the south. If north, same thing, okay? So we name wind by the compass direction it blows in. So whether it's north, south, east, or west. Take some time to write notes down as well. Okay, so when we talk about wind, we say a north wind blows from the north towards the south, okay? That is what a north wind is. A north wind is when you say the wind blows from the north to the south. So, where does a south wind blow from? Like I said before, a south wind blows from the south towards the north. So the opposite, okay? Take some time to write this down. Okay, so describe the picture briefly. Okay, so before we get into this, let's continue on page 54. So beneath the paragraph we just read, do you see the picture? In this picture, this is what we call a windsock, okay? So airports, airfields, and ports often have a windsock. This long clothed tube shows both the wind direction and the wind speed. The higher the sock lifts away from the pole, the stronger the wind. Okay? So it's obviously called a windsock because it looks like a sock. And the windsock usually, which is placed in airports, airfields, and ports, it helps us determine the wind direction and the wind speed. Okay? So yeah, here I've written it down for you guys. Airports, airfields, and ports often have windsocks. This shows the wind direction and wind speed. The higher the sock lifts away from the pole, the stronger the wind. Okay, so do you see the sock right here? The higher it lifts itself, the stronger the wind is. If the sock is more towards, the pole, that just shows that like the wind isn't that strong, right? So if the wind was really strong, it would clearly fill the sock up and have it, blow towards this way. So yeah, take some time to write that. Okay, so what are prevailing winds? Okay, so let me just read that. Everybody, I'm on page 54, the paragraph on the bottom left. Okay, so prevailing winds. As well as local and seasonal winds, there are certain winds that almost always blow in the same direction. These are called prevailing winds. So prevailing winds are winds that blow in the same direction all the time. At certain places on the Earth, there are belts of high air pressure and low air pressure. The air pressure is low around the equator. For example, because the Earth's surface is very hot there, and the heat makes the air expand and rise, so lowering its pressure, there are three main belts of prevailing winds on each side of the equator. They are called the trade winds, the westerlies, and the polar easterlies. Okay? So we have three main belts. Remember that. Three main belts on each side. Okay? So the three main belts are called the trade winds, the westerlies, and the polar easterlies. They do not blow directly north-south between the pressure belts, however. This is because the spin of Earth causes the prevailing winds to spin to the side. The diagram below shows the position of the three main belts of prevailing winds. So as you can see, the polar easterly belt is on the top. So on the very, very top and the very, very bottom. The westerlies come right after that. They're below the polar easterlies. And the trade winds are right, like the equator is right between the trade winds. Okay, so I hope everybody's looking at page 54 at the image, all right? And you can see that they're blowing towards each other. Okay? So you need to know, and here we have it as well. So do you see the polar easterlies are both here, top and bottom. The westerlies come right after the polar easterlies, right here. And the trade winds are right outside of the equator, okay? What you need to know is what prevailing winds are, and prevailing winds are wind that almost always blows from the same direction, okay? So talk about the air pressure around the Earth equator. Like we mentioned, the air temperature is low around the equator because the Earth's surface is very hot. And okay, so I'm sure you guys know what the equator is. The equator is the line that the imaginary line that surrounds the globe. It is the hottest place on Earth, all right? And the temperature never really changes. So the air temperature there is low around the equator because the Earth's surface is very hot there. And the heat makes air expand and rise. Okay? Like we mentioned, how many main belts of prevailing winds are there on each side of the equator? So let me just write it down for you. So we have three main belts on each side. So we have three here and three here. What are the three belts? The first one is called trade winds. The second is the westerlies. Third is the polar easterlies. Okay? So you guys need to know the three belts we have of prevailing winds. Take some time to write that. Okay, so let's move on to the next paragraph on page 54, where I introduce you guys to the Beaufort scale, okay? So wind speed is a measure of the strength of the wind. It shows how fast the air is moving. We can estimate the speed of the wind by the effect it has on smoke, flags, tree branches, for example. Weather forecasters often use a scale worked out by Admiral Sir Francis Beaufort in 1805 for measuring wind speed at sea. His scale has been altered for use on land. The Beaufort scale goes from 0, which is dead calm, with no wind at all, to 12 and over, which is a hurricane. Look at the pictures below that describe a Beaufort scale. Okay, so guys, there's this, so obviously, like said in the book, you can tell the wind speed the wind, obviously, just by looking at the smoke or flag or tree branches, all right? But weather forecasters, so people who tell the weather, they are able to predict the weather through a scale. This scale is called the Beaufort scale, okay? And this Beaufort scale was created by a guy named Admiral Sir Francis Beaufort in 1805. And this scale helps us measure wind speed, okay? So as you guys can see, this scale has 12 different levels. See? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different levels, okay? 0 means dead calm, so no wind at all whatsoever. And then 12 and over, so whatever is 12 and over, being like major hurricane, the worst wind ever. Okay, and like in the picture I've provided you over here in the PowerPoint, you can see in picture 1, that the flag is not even moving. Nothing's moving. Do you know what I mean? Literally not even a breeze. And then you move on to picture 2, and you see a slight movement in the flag or in the branches. Or do you see the smoke above the like coming out of the chimney? So in the first picture, you can see that literally the wind is not even affecting the smoke. But in the second one, you can see the smoke kind of tilted. And then the third one, you can see like a wind happening. It's pretty obvious. And then as it goes on, like from 4 to 5 to 6 to 7 to 8, 8 is so when it gets to 7, stuff's coming out of that, like falling from the house. And then it just gets really bad. And 7, the house is not even, I mean, when we get to level 12, the house isn't even there anymore. The wind has completely taken it. So yeah, that is the Beaufort scale. That is how weather forecasters tell the weather. Okay. And yeah, it is a scale used to estimate the strength of the wind. Okay, so next question is, why is it sometimes important to describe wind speed accurately? So why is it important for us to just, say exactly how the wind is moving and not just saying, oh, okay, it's a windy day, you look at the flag over there. Well, it's for the safety of boats, ships, aircrafts, and oil rigs. Okay? Now let's move on to the paragraph on page 55. How can we measure wind speed? So, sometimes it is important to describe wind speeds accurately, especially for the safety of boats and ships, aircrafts, and oil rigs. The scientific experiment for measuring wind speed is called an anemometer. Okay? An anemometer has 4 little cups that turn in the wind. The cups are attached by a shaft to a meter, rather like a car speedometer or to a scale. The harder the wind blows, the faster the cups of the anemometer turn, and the higher the reading on the meter. Okay, so in your book, as you can see, there's a picture of an anemometer. Sorry, I don't know why I can't pronounce it. And yeah, here I've given you a picture as well on the PowerPoint. So basically, do you see the 4 cups over here? If there's like a heavy wind, it'll spin very, very quick. All right? And it has a meter on it down here, and it tells you how fast the wind is moving. So this is a device. So what an anemometer is a scientific the scientific instrument for measuring wind speed. Okay, so this is what helps us measure wind speed accurately. All right, so how would we describe an anemometer briefly? Okay, well, we know that it has 4 little cups that turn in the wind. All right, we also know that the cups are attached by a shaft to a meter scale. Okay, so obviously the cups are attached to a shaft and there's a meter scale. The harder the wind blows, the faster the cups turn. So the harder the wind blows, the faster these cups move, okay? And we will be able to tell what the speed is with the meter. Okay, so before we end this class, I'm going to read the Did You Know as well. So, did you know the trade winds get their name from the sailing ships that use them to carry goods from the oceans? That's actually really interesting. All right, so yeah, that's about it for wind direction and strength. I hope everything was clear to you. Just, I hope like you got to the end of the video. If you do have any questions or concerns, please do let me know. I'm always available to answer any questions. And yeah, that's pretty much it. So yeah, I'll see you next class.